Hello everyone, this is Sagrika from Campus Technology, a portfolio company of Times Internet. So as you can see on your screen, today we'll be talking about deep learning, which is a significant part of artificial intelligence and machine learning. In this video, you'll understand the meaning of deep learning, the various techniques used, and how deep learning can be applied in your day-to-day lives. Firstly, what is deep learning? Deep learning is a branch of machine learning which is based on artificial neural networks. It is capable of learning complex patterns and relationships within data. In deep learning, we don't need to explicitly program everything. It has become increasingly popular in recent years due to the advances in processing power and the availability of large datasets. Because it is based on artificial neural networks, which is popularly called as ANNS, also known as deep neural networks. These neural networks are inspired by the structure and function of the human brain's biological neurons, and they are designed to learn from large amounts of data. Deep learning, as you now know, is a subfield of machine learning that involves the use of neural networks to model and solve complex problems. Neural networks are modeled after the structure and function of the human brain and consists of layers of interconnected nodes that process and transform data. The key characteristic of deep learning is the use of deep neural networks, which have multiple layers of interconnected nodes. These networks can learn complex representations of data by discovering hierarchical patterns and features in the data. Deep learning algorithms can automatically learn and improve from data without the need for manual feature engineering. Today, deep learning has become one of the most popular and visible areas of machine learning due to its success in a variety of applications such as computer vision, natural language processing, and reinforcement learning. On your screen, you can see how deep learning can be applied for machine learning. So we have three types of machine learning under the umbrella term. So we have supervised machine learning, unsupervised machine learning, and reinforcement machine learning. Supervised machine learning is the machine learning technique in which the neural network learns to make predictions or classify data based on the labeled datasets. Here we input both input features along with the target variables. The neural network learns to make predictions based on the cost or error that comes from the difference between the predicted and the actual target. This process is known as backpropagation. Deep learning algorithms like convolutional neural networks, recurrent neural networks are used for many supervised tasks like image classifications and recognition, sentiment analysis, language translations, etc. We next have unsupervised machine learning, which is a machine learning technique in which the neural network learns to discover the patterns or to cluster the dataset based on unlabeled datasets. Here there are no target variables, while the main machine has to self-determine the hidden patterns or relationships within the datasets. And third, we have reinforcement machine learning, which is a machine learning technique in which an agent learns to make decisions in an environment to maximize a reward signal. The agent interacts with the environment by taking action and observing the resulting rewards. Deep learning can be used to learn policies or a set of actions that maximizes the cumulative reward over time. Deep reinforcement learning algorithms like deep Q networks and deep deterministic policy gradient, also called as DDPG, are used to reinforce tasks like robotics and gameplay. Now, we have various types of neural networks. As you know, deep learning models are able to automatically learn features from the data, which makes them well suited for tasks such as image recognition, speech recognition, and natural language processing. The most widely used architectures in deep learning are feed forward neural networks, convolutional neural networks, and finally, recurrent neural networks. Firstly, what do you mean by feed forward neural networks? It is also called as FNNs, which are the simplest type of ANN with a linear flow of information through the network. FNNs have been widely used for tasks such as image classification, speech recognition, and natural language processing. We next have convolutional neural networks, which are specifically for image and video recognition tasks. CNNs are able to automatically learn features from the images, which makes them well suited for tasks such as image classification, object detection, and image segmentation. And then we have the recurrent neural networks, which are a type of neural network that is able to process sequential data such as time series and natural language. RNNs are able to maintain an internal state that captures information about the previous inputs, which makes them well suited for tasks such as speech recognition, natural language processing, and language translation. Next, you can see some of the application of deep learning. First of all, natural language processing, in which the deep learning model can enable machines to understand and generate human language. Natural language processing includes automatic text generation, language translation, sentiment analysis, and speech recognition. Next, we have the reinforcement learning, where deep learning works as a training agent to take action in an environment to maximize a reward. Some of the main applications of deep learning in the reinforcement learning includes game playing, robotics, and control systems. And lastly, we have computer vision, in which deep learning models enable machines to identify and understand visual data. Some of the main applications of deep learning in computer vision includes object detection and recognition, image classification, and finally, image segmentation. Now, since we are talking about deep learning, you must be wondering what's the difference between deep learning and machine learning? So, to just clear your doubts, machine learning algorithm is fed by a computer and uses statistical techniques to help it learn how to get progressively better at a task without necessarily having been specifically programmed for the task. Instead, machine learning algorithms use historical data as input to predict the new output values. To that end, machine learning consists of both supervised learning, where the expected output for the input is known thanks to the labeled datasets, and unsupervised learning, where the expected outputs are unknown due to the use of unlabeled datasets. And what is deep learning? Deep learning is a type of machine learning that runs inputs through a biologically inspired neural network architecture. The neural networks contain a number of hidden layers through which the data is processed, allowing the machine to go deep in its learning, making connections and weighing input for the best results. Now, some of the key advantages of deep learning includes high accuracy. As you know, deep learning algorithms can achieve state of the art performance in various tasks such as image recognition and natural language processing. Secondly, scalability. Deep learning models can scale to handle large and complex data sets and can learn from massive amounts of data. Thirdly, flexibility. Deep learning models can be applied to a wide range of tasks and can handle various types of data such as images, texts, and speech. Then, continual improvement. Deep learning models can continually improve their performance as more data becomes available. And lastly, automated feature engineering. Deep learning algorithms can automatically discover and learn the relevant features from data without the need for manual feature engineering. Since we now know about the advantages of deep learning, it's also good to know some of the disadvantages of deep learning. Firstly, high computational requirements. Deep learning models require large amounts of data and computational resources to train and optimize. Second, requires large amounts of labeled data. Deep learning models often require a large amount of labeled data for training, which can be expensive and time consuming to acquire. Third, interpretability. Deep learning models can be challenging to interpret, making it difficult to understand how they make decisions. And lastly, black box nature. Deep learning models are often treated as black boxes, making it difficult to understand how they work and how they arrived at their predictions. I hope through this video you were able to understand what deep learning is, the various advantages of deep learning, some of the disadvantage of deep learning, and how deep learning is not the same as machine learning. Thank you.